Thank you for coming to H2O World. The title of this talk is Building Blocks for AI Applications. I'm an engineer on the project and Shivam is working with me and he'll be a co-presenter on this talk. We have a diverse team working across the world. We have 10 contributors working across 6 countries and this has come together really quickly, really fast. And everything I'm about to show you is thanks to the great work and effort put in by this team. So we'll break this into 2 parts. We are running short of time, so we'll try to do this in 20 minutes. We have 2 parts to this talk. The first part is why Q, what is Q, whirlwind tour of what Q is about, and then we'll end with how to extend Q. And then in part 2, Shivam will cover how to get automatic insights out of Q. So why Q? If you go back to the definition of analytics, it is information resulting from the systematic analysis of data or statistics. So in every analytical process, there are steps involved, which is ingest, prep, model, and deploy. And for the information that results from these steps, there are consumers at 3 levels. There's the data scientist who is involved with the process. Then there is the business user or the person who is comfortable with BI tools who takes a bit of the digested information but still is at a fairly low level. And then there is the end user who requires to see completely digested information from analytics. And so if you're going to build a system like this, what does it take to put together all the components and build this system? There's definitely the analytical ML AI process in the background, which is ingest, prep, model, and score. And all of these information, all of these processes are going to emit information. Like for example, from ingest you have raw data, and then from prep you have the transform data. From the modeling process you have model metrics and predictions, and from scoring you have the operational metrics. And all of these have to be stored in some database somewhere. And then on the other side you have user interface to look at this information in various ways, either visualization or ad hoc analysis or searching and filtering and collaboration. And so what does it take to build an application like this? We need specialized skills. We need data engineers, we need data scientists, application engineers, database engineers, and then for the UI, you need front-end developers, and front-end developers are generally not as good as doing visualization, so maybe you need data visualization specialists as well. And so if you look at this process, there's visualization at every step of the way. So for ingest, you need to be able to look at the raw data. Post-preparation, you need to be able to look at the prep data to see if the preparations have gone fine. And from models, there is model metrics and model interpretation and model diagnostics, those need to be visualized as well. And finally, when you deploy the model, you need to be able to look at the operational metrics and visualize it in order to make a decision when to retrain and redeploy the model. And so what is the, how do we go about this? I mean, do we retrofit AI on BI or do we retrofit BI on AI? So we think that is not the answer. The backend BI is too manual and reactive, whereas it has to be live, proactive and predictive, and ML algorithms are a lot better at doing this than humans, and humans in combination with ML algos would do a much better job. And on the front end, old school drag and drop models are, mental models are too clunky to use, and everybody understands search as a paradigm. We use search day in and day out. And so AI and BI, if at all put together, have to be able to work as a cohesive whole and not as an afterthought. And so in conclusion, building beautiful, usable, predictive apps is hard. Doing all this quickly is harder. And doing all this without a diverse set of individuals working on that team is like super hard. And so how do we simplify this process? How do we ease the development of these applications? How do we lower development costs? How do we reduce time to market? And so what we've been thinking about is how do we empower data scientists to be able to quickly prototype and deliver these interactive predictive applications directly to business users? And that is where we built Q. So what is Q? Q provides 5 things for building analytical applications. It provides a large-scale analytical data storage. It provides high-performance analytical search with a superior UX. It gives you beautiful, high-scale, ad hoc, interactive, automatic visualizations, point-and-click data prep. There's automatic machine learning under the hood with Driverless AI. And all of this is completely extensible. So the system itself is usable by itself. But if you want to extend it, it is extensible using just Python. So both the backend and the frontend can be extended using Python. There's no frontend programmers required, no UI development required. And so what we're trying to do here is ask if building predictive applications should take months, weeks, or days, or can it be done in hours and minutes? And this is what the system architecture of Q looks like. We have a Q core, which is the 5 building blocks that I just talked about. And then there is Q apps, which is your extensions to Q and your AI applications that ship with Q. So there's a fast analytical database, there's a column store, parallel vectorized query execution. It's optimized for analytical queries, and it's really, really fast. When you load data into Q, this is what it looks like. You can see an overview of the data. You can look at the summary statistics, histograms, min-max for each of the columns. If you have string columns, you can look at the frequencies of all the members in the dimensions or the levels in the categoricals. There is columnar compression. We support both zlib and zstandard. There is fast search with type ahead. It's a low latency keyword search. We build in-memory indexes on demand, and it's optional. There is IDE style fuzzy matching, type ahead on anything that is there in the data set. So look for keywords, the dimensions, the columns, and also NL phrases as well. It's a resilient parser and an incremental parser. So it's very forgiving. So you can just keep on searching for terms that you want to look for, and you can go back and correct them later. And there's a whole bunch of keywords in there that it supports. There is the usual aggregate functions. There are you can look for time grains, yearly, monthly, last 6 years, last 7 years, top, bottom, sort by, all those work. Then we have interactive graphics on the front end, which is not a charting library, but it's very tightly integrated with search and with the analytical database, and the graphics are based on Leland Wilkinson's famous grammar of graphics, and he is an advisor on the team as well. So it was great working with him on this. That's what search looks like. There's usual suspects like this is a bar chart. It can be transposed. You can look for like top and bottom, and then you can add a number to it, say top 15 or bottom 15. You can put multiple measures in there and look at multiple variables simultaneously, or you can facet them by other categories. There is temporal charts, so line charts, time series. Again, you can see multiple measures against time, and then you can overplot them to look at them side by side. There is because it's based on the grammar of graphics. There is you can switch the geometries on the fly as you're looking at it. So these are like grouped area charts. And again, everything can be faceted if you have more grouping variables. You can look at all the data. So this produces a strip plot where you can look at every row. Instead of looking at aggregated data, you can look at every row in the data set and color them in different ways. Scatter plots, if you use 2 continuous variables, and those get faceted as well. If you have lots of continuous variables, you can also turn them into sploms, and of course you can go crazy with this and make facets of sploms and so on. All of these can be saved in notebooks, which is meant for sharing, and notebooks are they're not like Jupyter notebooks, but more like an ability to save all the visualizations that you did and add some notes to it, which support Markdown, and then share it with other people. We have self-service data preparation. There is a UI for adding transformation steps to a pipeline and then executing those. You can create arbitrary columns. There's a language called QLang in there, which is very similar to Python or Excel expressions, and you can use those to materialize columns and munch data at scale. And the QLang standard library has got 125 plus parallel distributed functions, and you can join tables and at scale as well. And then we have an example of NLP in pipelines, which Sri covered in the morning, where it's not just operations you can do in the database, you can do out of database as well. And so in the example that we saw in the morning, you can extract sentiments from text on the fly, and then those are available to you as new columns, which you can then visualize in the same system. And so here we have extracted the sentiment from the review, and then we're looking at it by province and visualizing that in various ways. And the last big feature of Quantum is you can build predictive models in the system using driverless AI. So Q is sort of a shell around driverless AI, which gives you visualization, search, database, and extensibility. And so you can easily go in there, go into Q, create a model. There's a simplified interface to driverless AI, and then immediately look at the results of mix and match the predictions with the original data set and visualize that in the same system. So it's not a retrofit like what is done with AI and BI. And then finally, there is Q apps. Q apps are our extension mechanism. They are authored 100% in Python. And so we have engineered Q for extensibility. And so apps in Q can read data, write data. They can wait for user inputs. They can write results back to the interface. And they are all managed by the system. So you don't have to be a front-end developer to be able to build rich user interfaces using pure Python. So it's almost like what Microsoft did with BASIC. They made Visual Basic. This is Visual Python. And this is what it looks like in Python. So every line that you see in here creates the corresponding control that you see out there. And then we've been dogfooding this, and most of the stuff that we have in Q is built using these Q apps. And so data connectors, pipelines, automatic insights, which Shivam is going to show now, they're all built using recipes. And so all of these wizards that we have in Q, like when you run insights in Q, it steps through analyze table, pick your columns, and then what do you want to save that report as, and then it goes and analyzes all the tables and produces insights. So all of this is authored in Python. There is no front-end programming involved. And that's it. So those 5 pieces combined with Q apps, that is what Q is about. I'll hand over to Shivam now, who will demonstrate one of the applications that we built, which is automatic insights. Thank you.
Thank you, Prithvi, for all the introduction. So let's look at the demo of automatic insights which are generated by Q on any data set which can be structured or unstructured in nature. So for this demo, I'll be taking hotel customer reviews data set, which is collected from more than 100 sources. And once this data is collected, it creates huge amount of unstructured text data. Now, for a business person, or let's say a hotel owner, some of the key questions that they might be interested in by looking into that data is, what is the average customer rating? What are customers generally talking about? What are they liking about? What are they disliking about? What is the sentiment? How sentiment changes over time? Are there some anomalies? And some other interesting stuff which they expect from the data. Now, all of these questions can be answered, of course, by manually reading those reviews, but that may take huge amount of effort and huge amount of time. So let's take this example and let's see how Q can help us answer these questions. So this is the data set which is collected by the company called Datafinity, which is a data procurement company. And this data set contains about 25 columns. We can see some of the details like address of the hotel, category, the reviews. We can see the review text, review title, user, city, etc. So a bunch of details about user, hotel, and the review. And of course, we can drill down into the row level views in which we can read more reviews or more data in more granular detail. For instance, here, this is a review text column, which is a huge bulky column, contains free text written by different customers. And now we want to find those answers automatically using Q. So that's where we can just click a button in Q, and it will start analyzing. So here is my data set. And what I'll do, I'll start analyzing this data set using Q. It asks for certain questions like what kind of insights you are looking for. Let's say I'm interested in anomalies, data distribution. I want to understand what people are talking about. So what are the keywords, phrases that they are mentioning, and of course the sentiments. So sentiment is not present by default in the reviews data, but I want Q to automatically derive it. So I can select, let's say, all the columns. And now what Q is doing is it's connecting to Q core, which has an automated insights engine, which is slicing and dicing the data in multiple fashions. It is deriving numerous interesting patterns, numerous interesting information and insights that aim to answer those generic questions that anyone is interested in from a data set like this. So let's see what happens when this is completed. So that analysis is complete, and we have a populated report or a notebook which contains all the different insights and information placed in a manner in which there is a visualization which quickly enables the user to understand, okay, what is inside my data. And at the same time, there are also narratives which provides interpretations of the graph. For instance, this first chart is about the rating distribution. As the hotel owner may see that most of the ratings are about 4 and 5. There are some which are like 1. So hotel owners might be interested in why there are 1. So that's where they can dig deeper and find out more such patterns. This is what are the most keywords and phrases mentioned by the people in the customer reviews. So people have mentioned about breakfast, cleanliness, staying, etc. And of course, not just unigrams or single words. We can also identify some of the phrases which people have mentioned. So like friendly staff, room cleanliness, great place to stay. These are some of the top phrases which appeared in all the data. And we have similar for review title. People again mentioned about location, etc. And all of this is automatically generated. All of this is, there is no code. It is automatically running different algorithms and scripts to identify interesting insights and patterns. For instance, the next one talks about sentiment. So it says that about 75% of the reviews are positive reviews. They have positive sentiment. There are about 20% negative, and remaining are like neutral. So now this red portion might be of interest, like why people are giving negative reviews. So that's where we can dig deeper into the data, which I'll just show. But here in the narratives, we can see some interesting narratives, like 100% of the reviews were positive during the months of October, February, and May for these years. So now this is a trend. This is maybe a unique pattern which Q identified in the whole bunch of those data and explains it in a form of a narrative and insight. It also identified that there was a date column in the whole data set. So it also shows the change in sentiment over time. It automatically generates these line charts for the positive as well as the negative. Now, as a business user, we can quickly see that there are some interesting things happening over here in which, like somewhere towards the end of January 2018, positive sentiment dipped a bit and negative sentiment increased at this point of time. So now I want to get more actionable insight, and I want to know why this specific thing happened. So that's where I'll go to search interface of the same data on the same data source, and I'll start asking questions like what happened on that specific date. So let's say I add review sentiment. So as we can see, this is negative, neutral, positive, what we saw. If I add, let's say, date added, let me select only the negative ones because we are interested in why that negative peak appeared. So here we can see, like, this is some pattern which we saw in the same notebook as well. We saw a big peak in the negative sentiments, and now we want to understand why this happened. So we can further slice it down. Let's say the date is 2018 we can see there are about 36 such rows which talks about negative sentiment, and here are all the negative reviews which were negative, which were posted on that specific date, like people talking about expensive parking, launch service was poor, no AC, etc. So now as a business user, how it started, the whole journey started by adding in just a data, getting a bunch of insights in a report and a notebook, then finding out some actionable items that we can identify, and then started asking questions like what happened on this date. Like maybe we can also identify for specific hotels. Let's say I filter down by hotel names. I'll just pass on the Hilton Hotel. Okay, so there are no negative for this one. Rabbit text. Okay, no worries. So yeah, this was something which came out of this data. Another stuff which happens is anomalies. So in the last chart, we can see that this is number of reviews over time. And one interesting thing which Q automatically identified that there was a big peak towards September 4th. And it also identifies from the external data that there was a Labor Day week during that time. So probably the cause of this spike is due to Labor Day. So this is kind of an anomaly, that number of reviews spiked. And it also explains the possible reason, like likely due to Labor Day. In some another data sets, like this is an example of Aquastat data set, which contains some country names, latitude, longitudes, and it automatically identifies that there is some geocoding there. And in that case, it will not generate typical bar charts. Rather, it will showcase the same information and insights in interactive graphs and maps. So this chart is about total population with access to safe drinking water. So it explains that most of the regions have access to safe drinking water, but many countries of Africa have slightly lesser percentage, about 50 or so. So again, this is coming out automatically, but user also has flexibility to change some of the insights, some of the narratives. Like for instance, let's say there is a pure business person who just wants to generate different reports and different stories out of this data. They can in fact generate the same kind of reports in a journal-like style. So this becomes like a newspaper report, which is obtained automatically generated from any data which they posted. And what happens here is that now users has the ability to generate their own newspaper reports from the data, which contains different insights and different information. And of course, like as Prithvi also mentioned, that there are different algorithms and recipes which runs in the background. And every recipe tries to generate different information, different insight, and tries to answer different information from the data. For instance, this is a Walmart sales example, and it explains the correlation between the sales of Walmart stores by different variables like unemployment in the region, land area, fuel prices, etc. If it identifies there was an interesting trend or a correlation, it then also generates a scatter plot along with some regression lines so that these charts become more meaningful, not just for business folks, but also for statisticians and machine learning people. And in the end, like, again, similar type of anomalies we can observe. Like here we have weekly sales jumped up during the last week of the year, which is probably due to Christmas Day. Again, identified from external data sources, which was not added into Q. So at the end, users can generate these reports for any data, which may be structured, unstructured in nature, text data, or even numerical data, and they expect they can generate such kind of reports, such kind of automatic insights, and then can obtain actionable insights out of it. So that's pretty much it from the data from this demo. Thank you.